Hello, everybody. Welcome to the webinar, Smart Construction, Digitizing Your Job Site with Komatsu and Skycatch. My name is Jackie Gilbo, Director of Marketing at Skycatch, and I'll be co-presenting with Erin Marsh, the National Technology Solutions Expert at Komatsu Australia. So, Erin, do you want to go ahead and advance the slide, please? So today we're going to talk about the opportunity for you as a user or business owner and what an actual workflow could look like when you're adopting a more digitized and precise workflow, and of course, the solutions behind this opportunity. At the end, we'll leave time for questions. Please enter them at any time during the webinar in the chat window. I'll be monitoring them throughout the webinar. So that was our introduction, but I would love to see who's on the call and launch a little poll here that best describes your experience with drones. So take a second there, and if you could please answer that, we'll move on with the webinar. So the responses are still coming in, but it sounds like most people have completely integrated drones into their construction workflow. So it sounds like we have some pretty advanced users, and I think that the good thing about this presentation is we start with our solutions, we show what's out there, but I think you'll still learn something even if you are using drones in your everyday work. Do you want to advance one more? So in construction, as you guys know, everything has a cost. On large projects, you could spend multi-millions per day, and it said that 15% of these costs can be attributed to rework, due in part due to inefficient communication or just a lag in the information getting to the right people in a timely manner. How many times have you thought to yourself or said to another person that you just wish you'd known about something sooner? Go ahead and advance the next slide. These use cases and the benefits to employing a UAV system directly overlap. Oftentimes, inefficient or time-consuming activities on a project can include disagreements with subcontractors about how and where assets are going to be moved, inefficient billing, updating stakeholders, and of course, mistakes happen, but they set the project behind and can create costly change orders. Catching a mistake sooner means that you're able to save time, money, and bid significantly more efficiently next time, compounding the success on that first project. Our customers experience a 2,000% more efficient topographic survey, both in speed and accuracy compared to traditional methods. And an easy and effective way to alleviate all those inefficiencies I mentioned earlier are to introduce drones and automation in order to set up a single source of truth that everyone can access and collaborate on. Do you want to advance the slide for me? So this is a picture of our viewer. It's in a online cloud tool. So here, this is our single source of truth that everyone can access. Skycatch offers these tools where you can stay updated on the project. You can share data with unlimited users, markup, measure, overlay CAD drawings. So if something's out of line by the centimeter, you can see it immediately. By integrating daily flights into your operations, you're able to start each day with the most up-to-date data like you see here. Drones and Skycatch in particular provide the platform to increase this communication and lessen those uncomfortable knowledge gaps about a project. So go ahead and advance to the next slide. There are two solutions available to you after this webinar. First, go ahead and advance next slide. There you go. Okay. So first, there's a completely integrated workflow, which Erin will talk about, and that's with your heavy machinery operations. But if you're only interested in just one single enterprise UAS, Skycatch offers a single kit that you see here. This contains the Explorer 1 drone in the upper right corner, which is our GC ground control point solution. So built on the M100 platform with a custom 20 megapixel camera, takes 1 photo per second, which is twice the speed of existing solutions. And then on the left there, you see our Edge 1 GNSS space station that combines an edge compute module. So by integrating a GPU with our GNSS systems, we provide the industry's fastest time to data. So in 30 minutes or less, you can receive 2D maps, 3D point clouds without even needing to find internet, cellular, or network connectivity. And lastly, the viewer, which I showed earlier, this is our point cloud processing tool that allows you to mark, measure, overlay, and analyze with unlimited users and flights per site. So now I would love to invite Aaron to take it away and talk about the smart construction workflow.
Thanks, Jackie. So my name is Aaron Marsh. I'm the National Technology Solution Expert Manager for our Smart Construction business model within Australia, New Zealand and New Caledonia. Currently, Komatsu Australia, led by a Komatsu global team, has a smart construction business model where we deliver factory integrated machine control to our customers through services and solutions like smart construction application for project visualization in a variety of 2D and 3D viewing platforms. One of these key tools is the Skycatch high precision package, which we call EDD, Everyday Drone. This includes the latest technology in UAV hardware and on-site processing tools like the Edge One. We currently have around 11 CASA approved commercial pilots in Komatsu team and a chief pilot to manage our company commercial operators certificate. The smart construction business for Komatsu is the future for the industry, and partnering with Skycatch gives us the edge in total site data capture required for project visualization. Komatsu is a manufacturer of utility, construction and mining equipment, and over the past 6 years has been a key driver for change in the ways OEMs typically do business, leading the way in technology and innovation in the solution-based business. We have currently around 60,000 employees worldwide, which grew dramatically with the Komatsu global acquisition of Joy Global, now Komatsu Mining. This acquisition has given us a much deeper product range and introducing many new technologies and solutions for our global teams and customers. We manufacture and deliver integrated, intelligent machine products through a range of dozers and excavators, and have for many years led the industry here in Australia for autonomous haulage systems. The smart construction offering here is about providing an end-to-end solution for our customers, following our brand management and customer focus initiatives that we have done successfully for many years, now combining many technologies and solutions to be the leader in digital transformation of the construction site together with global partners like Skycatch. We're now heading into the fourth industrial revolution, and right now we see rapid technology growth and acceptance in the industry. We all hear words IoT, big data, cloud, UAV, drone, integrated machine control, and disruptive in common day-to-day conversations. And this is very true for Komatsu and partners like Skycatch. We are now in a digitalisation phase where there are so many technologies emerging in the industry, and most of them are fantastic in their own right, but in the same token, they are very silo in the connection to other technologies and solutions. Therefore, our goal with Komatsu and Skycatch is to connect these processes in one platform that can ingest data and project information quickly, accurately, and usable as we move from digitalisation to digital transformation. This includes all aspects of the project from pre-tender to completion, providing a total connected end-to-end solution for our customers. In the picture on the slide, we show how Komatsu have changed the way traditionally we do business, which was very much concentrating on just selling the iron. And we were very successful at doing this, and still are. However, with the integration and development of technologies like intelligent machine control, we very quickly realised that although this machine technology was amazing and at times increasing productivity up to 60%, it was only improving a very small percentage of the project improvement and cost. Therefore, we had to improve whole processes within the project to ensure we maximise the gains in productivity and data collected from the IMC product. What came next was the realisation that our new technology cannot be everywhere on the project at the same time, and the integration of Everyday Drone program was formulated to connect all job site information together in partnership with IMC technology. We're now using Everyday Drone from the beginning of the projects to collect whole site information from pre-tender and bidding capability, comparing against 3D design surfaces, providing fleet and project managers real, accurate information viewed in the smart construction application so that we can work out their cut and fill volumes with accuracy from the beginning, enabling the project tender teams to select the right machines for the project, optimizing fleet recommendation, and customizing the construction method, making right decisions from the start. This doesn't stop at the beginning. Visualization and accurate data collection in near real time throughout the entire project is vital. Being able to give the customer, supervisors, project teams the ability to make decisions throughout the project easily with usable accurate data is key to success of the project as a whole, not just in silo environments, but whole site decision-making processes. Making informed decisions about changes to what was planned and what is actually happening on the site in real time is paving the way, optimizing the construction process, and ultimately providing greater productivity, increased profit, and reducing project risk from beginning to end. We can all collect data one way or another. The challenge we all face is collecting site and project data and having it delivered to the people that need it on the project to make timely decisions throughout the entire life cycle from beginning to end. This data needs to be collected quickly, and the output needs to be usable, accurate data. Komatsu IMC machines collect as-built information from active working areas every 30 minutes, which is delivered to the SmartConstruction cloud server and usable by the project team instantly. On the other hand, having as-built collected by only Komatsu IMC machines means we would have limited data collection on all areas of the project where material is being moved. Therefore, partnerships with Skycatch is vital to this accurate, timely data. We as an OEM understand that we cannot own 100% IMC market share on any one particular project, and we must still provide our customers correct site information like as-built for them to make informed decisions of the project, like what is planned versus actual. Skycatch Everyday Drone allows us to collect data from IMC machine and the UAV to capture multiple active working areas. The UAV collects accurate as-built information where IMC machines aren't working, and recently with new software updates allows seamless data uploading from the Everyday Drone and Edge platform in the field straight to the SmartConstruction server, where our customers can use accurate real-time data in their decision-making process when they need it, not hours or days later when it's too late. If you have a look at the slide here, you can see on the left-hand picture, this is one of our IMC integrated machine control excavators, and the color map in the top right-hand part of the picture shows the as-built collection from the machine. In this case, the green is plus or minus 50 mil. As it gets yellow, orange, and red, that's above grade. When it's blue, it's below grade, a bit like the picture in our intelligent machine control dozer on the right. As that data is collected from the machine, it's uploaded to our SmartConstruction application every 30 minutes. So supervisors, project managers, foremen can see this data accurately on their site and visualize actually what's happening in their environment very quickly. The only thing is that IMC machines here in these scenarios here are only collecting as-built data in very silo environments of their active working areas. So unless we have 100% market share on site where there's many IMC machines, we need other methods to collect whole site data, and that method is the Everyday Drone. So we fly the Everyday Drone to pick up as-built information from other parts of the site where other machines are working, people are working, where there's material movements, we can collect that data and then upload that straight to SmartConstruction application as well. So this is a bit of a customer walkthrough on one of our sites over here. So I'll just take you through what that looks like. We were given a 3D design model for the project and uploaded this data straight to SmartConstruction application. And we also uploaded it to two intelligent machine control machines that were allocated to this project. And this is the tin here on the left-hand side for sort of small to medium sized residential project. We then arrived on site and set up the edge on a 2-metre survey pole, which you can see in number 2 here that's me putting the edge onto a known point, with bipod legs on a known point, which was surveyed in from a high accurate state survey mark and coordinated to the local coordinate for the project so that everything would tie in perfectly. We started the edge and input the coordinate values X, Y, and Z and started logging the position straight away. We then prepared the Explore 1 UAV, and this took around 10 minutes, and by that time we were in the air. The flight on site was around a 2-battery flight. We flew at 60 metres with an overlap, front overlap of 85%, a side lap of 70%. And the flight for this site took approximately 20 minutes of flying time to complete the mission. After the Edge 1 landed, we powered off and removed the SD card. We put the SD card into the Edge and open Edge 1 app on the tablet, and we stopped the logging to the static position and installed the SD card. This was approximately a 5-minute task. What came next was a few simple steps. And this was the first flight we conducted on the site. We then selected the SD card and transferred the flight data to the Edge, approximately a 1-minute task. We selected the quality of the data to be processed. In this case, we selected standard, along with the actual output we required. We selected a point cloud in TXT format, the orthomosaic, the TIFF, and a ground return, which is the point cloud with objects removed, which is the most important for us as for the as-built, as we don't want trees, buildings, and obstacles in the volume calculation. The Edge has all the Australian projections and geoids available in it, and the project was created on MGA 94 and AusGeoid 09, so the selection here was seamless. After selecting the correct ESPG code, 28356, in the Edge app, we could then select Process. To process the data, this took about 45 minutes to complete. In this time, the Edge returned all of the outputs while we were on site before leaving to another project. Once processed, it was as easy as sending the processed data back to the SD card and installing on my laptop. In fact, we processed and sent to Smart Construction application within minutes of the process finishing, and I was able to show the site supervisor what his site looked like before leaving, so he could make decisions on the project with usable, accurate data in almost real time. So this was me after the flight and processing in my car on the Edge with no connectivity needed. In this 45-minute period, the Edge returned all the outputs, including the point cloud ground return, objects removed, which is amazing in its own right in that time. The processing time of the Edge returned actual accurate coordinated data on the site. It's so fast and the workflow is simple. Here in Australia, we need to have the processing done in both known and local coordinates. And the great thing with the Edge is it can handle projection and local coordinates, no matter what that is. So this is just a pictorial of the site. In this case, we did the first flight. We can see the ortho image, the up-to-date ortho image. A lot of trees needed to be removed. Obviously, we're not going to get an accurate a survey accuracy as built from this site. But what's important about this pre-tender flight was that we could actually see how much of the trees and grubbing needed to be removed. And then we can actually, as we fly more often, we can check the process and collaborate on site with all parties of the project. We then did a topo survey once the trees were removed, and that was then sent to Smart Construction application, which is the view that you're looking at now. Once we got that data, that clean data of the as-built with the objects removed, any of the trees that left, the buildings, people on site were removed from the process. We then put in the 3D design file, which you can see here. And that 3D design tin was then compared to the UAV survey, giving us our cut and fill volume report. And the cut and fill volume report is important then to tell us what we have to actually move, but more importantly, also looking where our cut and fill is so we can select the right resource for the project immediately. And in the future, this will be automated for our customers. The design file here was just imported as a TopCon and Komatsu file format, so nice and simple, drop and drag. Here's the as-built map compared with progress. So the first thing that SmartConstruction application does is, and we spoke about before earlier in the slides, is as the machines operate, both our intelligent machine dozer and excavator, it collects as-built from the machine. And in this case here, you can see the color change of the map. So the red is hasn't been touched by a machine, or the UAV hasn't flown. But you can see if we continue this process and only allowed for as-built collection by our machines, it'll be in a very small area. So what we need to do is we need to capture that whole working area for the project. And the way we do that is using Everyday Drone. This is a compilation of what it looks like after we've got obviously the map, up-to-date drone survey, and also 3D data. On the left-hand side, here's our cut fill map, and we can see the key on the right-hand side. That shows us what cut and fill we have. And it also shows us down the bottom the amount of cut and fill that we have. So in this case here, we had 6,376 cubic meters of fill and 16,989 cubic meters of cut. So we automatically can make decisions on the project on what needs to happen. Obviously, we've got a lot more cut than fill, but there's also multiple stages in this project that we can use that for. The cut and fill map up the top, obviously this shows you where we need to cut. So in this case, the blue is undergrade and the red is above grade. So we can move red into blue to make green. It's that simple. But you'll see down the bottom here as well, it gives us percentages of our fill and our cut ratios. And what that means is that as the machines operate, they will automatically every 30 minutes upload to the SmartConstruction cloud and update the percentage of task completion. So in this case, 5% and 11%. In combination with the UAV, we can fly the drone, the everyday drone, and then it will update that as-built as well as regularly as we fly. And because we get quick processing on the edge, pretty much the foreman can fly the edge and have data back in active areas in around 30 or 40 minutes to make the right decisions on the project at the right time. Here on the right side, we can see data collection. So the dates on the circles show us when the data was collected. And that's both collected by IMC machine and also UAV. So this was proving the accuracy to the customer. Everyone always talks about accuracy of UAVs. We're very confident in the accuracy of what the UAV and the Edge is producing. And this was a method we used. So this customer in particular did a total station survey for an as-built pickup for the client. And we also, on our own batch, just put in a couple of checkpoints. There's a couple of the guys in the team just putting some checkpoints out. Just to confirm the data after we did the flight. In this case here, obviously the total station survey was done, and then from that we looked at the data. So we flew the UAV. We processed this in about 30 minutes on site using the edge. Obviously no cloud processing, purely processed on site. And we used the checkpoints we put in compared to the as-built collected by the total station. And you can see the results there. So the average over the Z, so the elevation, was 26 mil. We were very happy with that, and the customer was extremely happy and very surprised on the data output from the edge. So if we can obviously get the repeatability of this, which we are right now here in Australia, that's amazing technology to have on site and a good tool for a project. So as you can see on the slide here on the left-hand side, the video shows the project progress change in 2D over a 21-day period. This is the same site we just looked at. This was collected by both IMC Dozer and Excavator, along with a weekly Skycatch everyday drone topo survey, which was processed on site with the Skycatch Edge 1 and uploaded to Smart Construction application. The picture on the right illustrates the same timestamp of the project, but is looking at the cut and fill material movement, comparing the 3D design surface with combination of IMC and UAV as built pickups. On this particular site, there were two IMC machines, a D65 EXI-18 power angle tilt dozer and a PC360 LCI-11. And the as-built from these machines was only collected in their specific working areas. Without the Skycatch everyday drone technology, Explore 1 and Edge 1, it would be impossible for the site supervisor and project team to visualize and collect the data from the whole site in almost real time. With accurate collection of the site information and as-built, the customer was able to match his project plan to actual and make timely decisions in the construction to ensure the project stayed on time and budget. It also allowed them to collaborate with their own workers, contractors, government, and EPA, Environmental Protection Agencies, through the project with real-time data and visualization tools, with the deliverables from the edge processing and IMC technologies viewable in Smart Construction application. If you would like to know more, please reach out directly to me. My contact details are in this presentation, or contact your local Komatsu team or distributor. Smart Construction is the here, it's the now, and the digital Smart Construction connected sites are fast becoming the norm. Thanks for listening, and I'll hand it back over to you, Jackie.
Thanks, Aaron. So if you registered with a valid email address, we'll be sending a recording of this webinar to you after, and it will be available also on all of our social media channels. So you can always reference it again, but I'll give the audience a few minutes to enter any questions you have. A few already came in that we could start with, but go ahead and enter any questions. So Aaron, with the sites that you did, were there any distance limitations with your flights?
Was there any what, sorry?
Distance limitations.
Any distance limitations to the flight on site?
Yeah, so that came in during your presentation about, when you're doing these tests, what were the distance limitations and if you had any issues around the length of the flights, I guess.
Yeah, look, the beautiful thing about using the Edge 1 is that we fly active working areas, and on the larger sites, we do multiple collections. So with the Edge, we can actually process and collect the positional information as well during the flight. So for the residential areas, the active areas, we'll easily collect something like 600 by 600 meters, easily processed on the Edge, move to the next site while it's still processed, and next part, move to the next flight area, fly again while it's still processing, still collecting data, and continue that process as we need to. But we're not flying the whole, say, a 5K alignment at once. We only need to collect our as-built information from active working areas that are actually where materials being moved. So we manage that quite easily.
Great, thanks. So I'm assuming that this is a question for both countries, but one of them was, what special licenses do you need in order to operate the drone? So for commercial purposes in the US, it's called a Part 107, and there's a lot of resources online that help you train. And for the Skycatch system in particular, we have tons of resources, both documented and video. And Aaron, do you want to talk about what licensing or certifications you need in Australia?
Yeah, so in Australia, there is some laws, or CASA say that under 2 kilos you can fly as a hobbyist and also as a commercial pilot. But the thing is, under 2 kilos, you can't get insurance unless you have your CASA approved certification. So anything you're doing with commercial operations like we do, we have to do a CASA approved, so Civil Aviation Safety Authority course, where we get our operator certificate, and we also get our AROC so that we can use VHF to talk to the CTAF or any control towers in restricted or controlled airspace. And without that, you can't fly. So you also need in Australia a chief pilot, so a company operator certification. And there's a couple of ways we can do that in Australia. One is you become the chief pilot for your business, which takes some time with CASA to get approved. Or you can use a third party, like for Fly Freely or something like that, that becomes your chief pilot.
All right. Can you calculate quantities of loose and solid dirt separately?
So say that question again, please, Jackie.
Can you calculate quantities of loose and solid dirt separately? Was someone's question.
Well, so that would be, so we can add in Smart Construction application, for example, if we get compacted material, so banked material, we would just calculate the volume and compare to loose, and we know the BCM, so we know the specific gravity of compacted clay, for example, versus loose clay. So in this case, we just calculate and times it by the specific gravity of the material. It's a quite easy calculation. In SC apps, so Smart Construction application, there will be, not right now, but there will be an automated process where you can select the material or geographical information of the material to do that.
Perfect. Okay, let's do one more. Do you need any special surveyor training to be able to use this tool? I'm sure they're referencing the EDD.
Yeah, so the everyday drone, other than the CASA certification in Australia, you could learn how to use this process in about 10 minutes. Automated flight, and the process workflow is very simple. You pick it up in 5 to 10 minutes. Very easy.
Perfect. Well, thank you everybody for joining. This is all the Skycatch information on the website. This is our sales, Twitter, LinkedIn. We're also on Facebook. And then if you want to advance one, Aaron, then there'll be all of the Komatsu contact information. So we really appreciate everybody joining. And again, you'll get a copy of this presentation after. Thank you.